All right, moving into chapter 3, we start getting into systems of equations. A system of equations is two or more linear equations that look like this. Ax plus by equals c, dx plus ey equals f, where those capital letters A, B, and C are just any number, and D and F are any number, and then X and Y are just the variables in the equation. All right, and a solution to a system is an ordered pair that makes all equations true. It has to make every equation true, not just one, but all of them. Okay, and as you write that down, if you have to pause, go ahead and pause the video. What we want to do in the next part is determine if the following ordered pairs are solutions to the system. So what we would do in number 1 is first you take the first equation. So that's the 3x minus 2y. So it'll be, we'll start there. So 3 times 2 minus 2 times 2 equals 2. Check, is this true? So does 6 minus 4 equal 2? Yes. All right. Secondly, take the second equation, 2 plus 2 times 2 equals 6. So does 2 plus 4 equal 6? Yes. So both of them would end up making it true, so the answer is yes. This is a solution. So did that ordered pair make both true? Yes. So is it a solution? Yes. The second problem, take the first equation, 3 times 0 minus 2 times negative 1. Does that equal 2? So 0 minus negative 2. Does 0 minus negative 2 equal 2? Okay, I'm going to do chop chop. Does 0 plus 2 equal 2? Yes. Then take that second equation. 0 plus 2 times negative 1. Does that equal 6? So does 0 plus negative 2 equal 6? No. So is this a solution to the system? No. So it's a solution of the first equation, but not a solution of the system. Okay, so it's got to make all of them true. Okay, so how can we find out how we do this? Instead of just guessing and checking and trying to find an ordered pair that makes all of them true. So like what you could do is you could try to guess and check and be like, okay, what x and what y will make the top equation true? And then what x and what y will make the bottom equation true? But trying to find ones that make both of them true by guessing and checking can be almost impossible. So what we can do is graph them. If we graph them, we can find out where they cross, and then that will give us our solution. So let's take a look. So if you take the top equation, the negative 2x plus y equals 5. So you add 2x, you get y equals 2x plus 5. I'm going to take that equation, I'm going to graph it in blue. So the y-intercept is 5, so I'm going to go up to 5. 1, 2, 3, 4, 5. The x-intercept, the slope is 2, or 2 over 1, so that means you go up 2 to the right 1, or you can go down 2 to the left 1. Okay. And connect your dots. So your line will look like that. I'm going to switch colors, and I'm going to graph the second equation. So I have minus x, y equals negative x plus 2. So we graph this equation. The y-intercept is 2, so go to positive 2, but then remember y and x. The slope is -1. That means down 1, right 1, down 1, right 1. Or up 1, left 1. So when you connect your dots, I just want to point out that every point on that red line will make the second equation true. And every point on that blue line will make the top equation true. But which point will make both of them true? It's the point that crosses both of them, or it's where both of them cross and intersect. So this ordered pair is -1, 3. So the solution is -1, 3. How do we check our solution? We take the two equations, so top equation, and you plug it in. So we would get 2 plus 3 equals 5. Yes. Take the bottom equation, plug it in. -1 plus 3. Does that equal 2? Yes. So this ordered pair where they cross, that ordered pair is a solution to all the equations because it's where all the lines cross. And that's one way to solve it, like instead of trying to guess and check, that would take forever. Okay, example 2, same thing. So if we graph these, I'm going to graph the top one first. So I'm going to take 2x minus y equals 2. I'm going to solve for y. So minus 2x. I have -y equals -2x plus 2. How do you get rid of the negative? Divide everything by -1. Y equals positive 2x minus 2. So if you graph this, the y-intercept is -2. So put that on there. The slope is positive 2, so up 2 to the right 1. Up 2, oops. Sorry about that. Up 2 to the right 1. So you connect your dots. Okay, then, I'm going to change colors. I'm going to graph the second line. That one is already in slope-intercept form. The intercept is 3, so go to positive 3. The slope is positive 2. So again, it's up 2 to the right 1, or down 2 to the left 1. What do you notice about the red line and the green line? And think about what is the same in the red line and the green line. So if you notice, the slopes are the same. The lines don't cross. They never will cross. So what is the answer? If you remember up above, the answer was where do the lines cross? That's the solution. If the lines don't cross, what do you think your answer is? If they don't cross, that means there is no solution. So you can put no solution, or this symbol works too. And this happens when there are parallel lines, because the lines do not cross. Okay, and then we'll do example 3. If I graph the bottom equation, I'm going to do that first because it's already solved for me. The y-intercept is 4. 1, 2, 3, 4. The slope is positive 3. Slope is with the x. So up 3 to the right 1, or down 3 to the left 1. You connect your dots. Okay, change colors. I'm going to graph the second line now. So -6x plus 2y equals 8. Solve for y. You would add 6x to get 2y equals 6x plus 8. Divide by 2. Y equals 3x plus 4. So the y-intercept is 4. 1, 2, 3, 4. The slope is 3, which would be 3 over 1 again. As a fraction, 3 is 3 over 1, which means go up 3 to the right 1, or go down 3 to the left 1. So what do you notice about the red line and the blue line? You will notice is the exact same line. The slopes are both 3, the y-intercepts are both 4. So this would be infinitely many solutions. Because it doesn't cross in one spot, it crosses in all the spots in that line. So infinitely many, this symbol right here, you could write down infinitely many if you feel like it saves you time. And that happens when it is the same line. If it's the same line or coinciding lines, which means they cross at every single point, then it's infinitely many solutions. All right, and then the last part, a summary of today. So what we learned is that if the graph is a pair of intersecting lines, intersecting lines is where lines cross once, then we know there's the solution is one ordered pair. So if they intersect once, there's one solution. If the lines are parallel lines, so parallel lines would mean they don't cross. If they don't cross, they don't have a solution. The answer is no solution, which is that symbol. And then lastly, they can either cross once, they can never cross, or they can cross all the time. That would be the same line, or some call this coinciding lines. So same line or coinciding lines means there are infinitely many solutions. Because they cross all the time. So infinitely many ordered pairs. So we can have one solution, no solution, or infinitely many solutions. All right, and so far we've learned how to solve these systems by graphing.